Hi, I'm Jack. This is the fourth video in this series about my A-Level Computer Science NEA. I scored 70 out of 70 for my project, and hopefully I can help you get a high score too. For my NEA, I decided to build a computer game with some basic AI based on an old abstract strategy board game. In this video, I'll be looking at essential features, limitations, and computational methods in the analysis section of your NEA. So I'm going to start at the essential features part of this section. These are all key parts of the NEA if you want to achieve a high mark. This section should define the scope of your project, justify the complexity of your project to the examiners, and can help inform development. In part, it serves to ensure your NEA meets the standards for breaking the problem down into manageable, testable components. I'd recommend you probably want between 5 and 8 essential features altogether. I began this section by giving an overview of my initial concept, and then I used a table to list out each individual feature and justify its inclusion. It starts with me describing the GUI and continues for each feature of the game, ending with the AI difficulty settings. It's pretty much just exactly what it says it is, a list of the essential features to be included in your solution. They aren't called essential for no reason, so try to make sure you include them all in your solution, even if they're not 100% perfect. If you end up not having enough time to complete any features, and they aren't absolutely necessary for your solution to just function, I recommend removing them from this section and then including them in your evaluation as things you could do if you wanted to extend the project further. Okay, so now moving on, we have the limitations section. Now, this part again defines the scope of your project, and it demonstrates to examiners you've understood the constraints rather than just failing to finish aspects of it or deciding not to bother. It allows you to demonstrate some real-world technical thinking as well, because real software projects often have time, budget, or technical constraints. Now, for me, VI was the big concern in my project and contributed most of my limitations. I was worried I might not have enough computational power to run it effectively, and concerned about how effective the levels of difficulty would be, and whether I'd be able to create a good scoring heuristic for the Negamax AI. Most of my other concerns were generally down to connections, Wi-Fi requirements, and internet lag and the security of connection when playing over the internet. Anything that you're not sure whether you'll have the time or ability to fully complete can go in here, as well as any challenges you might face over the course of your project. Just don't make it a long list of things you just haven't bothered to do. So the final thing we'll be looking at in this video is computational methods. In this section, you're justifying why a computer-based rather than just manual solution is appropriate. You can state the problem and then break it down via decomposition, abstraction, and algorithmic thinking. So I began by explaining why my project was suited to a computational solution, which in my case was obviously because I had lost some of the pieces from the physical game, but I still wanted to be able to play it. The next part was problem recognition, where I attempted to move from some vague ideas to a more precise problem statement. I'm not really sure how well I managed this, to be honest. I should have been focused more on clearly identifying what the problem was, what wasn't possible, and the required solution. But I do seem to have just been more focused on waffling on about how many problems I was having. It doesn't really improve from there, I'm entirely certain. I'm not sure I had much idea about using abstraction in the context of my project, and I would say that decomposition probably needs to come before abstraction. What this part should state are the things you're choosing to ignore, which in the case of a board game could be things like the physics of throwing a dice. Ideally, then you'd explain why each of these elements aren't important. For example, you can just use a random number generator in place of a dice, and they only serve to add unnecessary complexity, so you just link it back to your code. I didn't really get this at the time. So now moving on to decomposition, I did have a bit more of an idea on this one at least. It's where you break your huge project down into smaller solvable problems. Now I basically just broke my project down into 5 simple steps and not gone any further than that. I feel like I should have come back later and added more detail once I'd done more of the project and had more of a concept of how it was going to look. I do talk about using divide and conquer to break the steps down so I can solve each step individually as a group of functions or class. Now I actually did do this in the algorithms part of the design section. However, this focuses more on breaking it down into classes and functions rather than breaking down a problem into smaller problems. The last part of this section is talking about the features of your algorithms, particularly the ones that make them computationally complex and worthy of being considered as a computer science NEA, because it has to meet certain complexity requirements. In mine, I talk about alpha-beta pruning, heuristics, and the recursive backtracking that the AI used. Overall, this probably wasn't my best section, but it does go to show that your project doesn't have to be 100% perfect to get a good score. So that's the end of the fourth video of the series. There's a link to the NEA in full below if you want to check it out, and in the next video I'll be looking at stakeholder requirements, solution requirements, and success criteria in your NEA.